Hey everybody, this is Larry. This is day 29 of the October Leetcode Daily Challenge. Almost to the end. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you find scary on today's problem. Maximize distance to closest person. Okay, you're giving away with, it's like social distancing or something, right? You're away seats I, you have empty seats, maximum distance. Um, okay, so what is n? N is 10, 2 to times 10 to the 4th, was that like 20,000? So 20,000 means that n squared is going to be too slow. So we should at least aim for n log n. But in this case, turns out that we could do it in linear time. So let's kind of compose this in one direction. Let's just say instead of just closest to the left and to the right, let's just say how do you find the thing that's closest to the left, right? And then the idea is pretty straightforward, I think, in that if you do that, you can have a linear time. Just keep track of where the last taken seat is, and then as you kind of keep moving from left to right, more seats will open up and so forth, and then you kind of just keep track of the maximum distance that way, right? And in a way, it's you could also argue that that's dynamic programming, maybe, in that you reuse previous states, right? Because if you're only looking at the left side, the number, so the closest seat is just the previous position plus one or is zero, depending on where that is true anymore, depending on the current seat is taken, right? So then now, okay, so let's say we store that. Let's say we store that information somewhere, right? And we keep track for every cell, what is the closest to the left, right? Well, then now we just have to go from the right and do the same thing. Because now we know for every cell, we know what is the closest to the left and the closest to the right, and then we just get the distance to the left and the right, the min of the distance, because that's how you calculate the distance in this case. And I think that would be enough to get you to linear time. So let's do this algorithm. Yeah, so let's just say left distance is equal to, let's just start off with, doesn't really matter, times n is equal to length of seats. Do I need to be, yeah. So usually on these things, sometimes I ask myself whether I want to answer the question of, do I need like the prefix before the zero? If that makes sense. But in this case, I don't. So that's why I'm thinking a little bit, but I'm off by one. So now we go for index. Let's just say taken in enumerate seats. Then left distance of index is equal to left distance of index minus one plus, or maybe I could phrase this another way, right? If index minus one is greater than zero and seats of index, I guess just this current one, right, is taken is equal to 2, 0, then we do this plus 1, right? Otherwise, we set the left distance is equal to 0, or you should set it to taken, I guess, actually, right? Because if, oh wait, I guess it's 1 minus taken. Because if this is a 1, then it's taken, then we should start with 0. And if this is a 0, then it should be 1, right? Okay, this one is a little bit too funky, to be honest, but and we could kind of write it out if you like, just so that the code is more readable, because this is actually not that readable, to be honest. If taken is equal to 1, meaning that if it is taken, then left distance index is equal to 0, else left distance index is equal to 1, right? So basically, now we keep track of left distance, and then now we want to go backwards. So there are a couple of ways to do the for loop. I'm too used to thinking in terms of a C-like language, to be honest. So I usually will write it backwards, but I'm going to try a little bit. So for index in range, we want to go from n to 0, which is, because of the range is exclusive, so we have to do -1, and we want to decrement by -1, right? So yeah, so now we track the right distance, right? So the right distance, now we don't need another way, though we can do it for symmetry and understanding reasons. So if you want to do that, you could do like right distance is equal to 0 times n, and then you basically do this, but going backwards, right? And checking index plus 1 instead. But we're going to just keep a rolling count, which is let's just keep track of the last good maybe, or last not taken is equal to n, just as like the border, and then now we can do if seats of index is equal to 1, that means this is taken, so that means that now now our current is gonna be maybe actually we could do a little bit better. We could just say distance is equal to 0. Say distance, and then if this is equal to 1, then we set the distance equal to 0. Else we set the distance increment 1, because if there's an empty seat, then we have an extra 1, right? So this just counts the empty empty space from the last seat. And then now, in the meanwhile, so now we want to keep track of the maximum distance. So I usually call something like best, but it's a little bit vague, but that's okay. Best is equal to 0, and now best is equal to the max of best or the min of distance or left distance of index. So this part is just, the current distance from the closest is going to be just the min of your left closest and your right closest, right? So like, for example, if there's one person 1 seat to your left and one person 3 seats to your right, then you just take the 1 seat, right? Because it's the closer one. And then max just get us the max distance from that. And that's all you need, I believe. We should have to double check like empty stuff and stuff like that. Also double check stuff like that. Oh yeah, this should start in n-1. This is why I'm more familiar with C++ loops, C style loops. Though maybe that didn't matter for this one. Seats is at least 2, so I guess this is not valid. Okay, 3. Oh, so there is a case where we don't count the boundaries as dumb. Okay, I think okay. How do I want to handle it? I did miss a case because I think this keeps track of the code. The way that we wrote it, it keeps track of the closest one, but not necessarily, in a necessary way. But we could actually fix this pretty easily, because from left distance, we can just add. So the 2 things that we need to add, one is that basically the edge case is such that on the edge it's going to be infinity. So basically we want to set, and this is where I said in the beginning whether matters, but now let's actually offset this by 1 so that we have an additional like borderline thing to handle the borderline, and maybe plus 2 so that we can kind of handle this for the right side as well. But distance sub 0 is equal to infinity. So if we do it this way, then it starts at infinity on the left if there's no 0, and then we only start counting when there's the first 1, right? And we can do a similar thing on the right side, Now this index is off by 1, and we start counting distance by infinity. And then now we have to kind of double check that, okay, one seat is occupied, otherwise we'll return infinity for some of these answers, which kind of makes sense, but yeah. Index, oh, oops, seats is, oh, this one, sorry, I was just changing my head, but we only have to change left distance. Yeah, something is a little off, though. Do I look at the right answer? Oh yeah, because right now, this is what happens when you start shifting things. Because I shift this thing without kind of updating this thing, right? So now, index -1 is greater than 0, still true. But now, what we want to do is we want to start the index at 1 because of the offset. I forget how. I think that's one of the parameters of enumerate, but I could be wrong. Let me double check real quick. Yeah, so I could just change this to this, and I think this will be okay. Because we want the because we want the index to be 1 based, right? Because we already changed the 0 to be the border instead. Okay, so this looks okay. Let's put in a couple more cases, given that we not very good about this. Well, by we, I mean me. Not that many more cases other than like running time issues. And because we have linear time, I'm not worried about running time. So yeah, let's give it a submit, and let's have a bad typo. But yeah, so that looks good. I have a lot of been into a couple of little things, but I think the general concept is still pretty good. So yeah, so what is the running time? We look at each seat once on the left side, and then another time for the right side. So 2 pass over 1 time for each seat. Given n seat, that is O of n time. For space, clearly we have left distance, so it's going to be O of n space. And yeah, you can actually, yeah, cool. That's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye bye.